Next, third question. See the third question in this page. What are the advantages of connecting electrical devices in parallel with battery instead of connecting them in series?
In parallel combination, the resistance will be a minimum. Defecting, if one of the devices is defective, others won't be affected.
Okay.
And in parallel combination, there are separate switches.
Okay. Two more are there.
Enough current can be drawn from the main line.
Very good.
And in parallel combination, same potential. All the devices will get the same potential difference.
Okay, very good. These are the main points. All devices will get same potential difference in parallel combination. Each device can draw enough current, depends on the power of the device. Then each device can be controlled by using separate switches. Then the defect in any one of the devices will not affect the working of the other devices. And finally, the total resistance in the circuit will be a minimum. Okay. Fourth question. How can three resistors of resistances 2 ohm, 3 ohm and 6 ohm be connected to give a total resistance of 4 ohm and 1 ohm? Any idea? Means we have three resistors of 2 ohm, 3 ohm and 6 ohm, and you can connect in any way, mixed connection, like means series and parallel, but we need total effective resistance in one combination 4 ohm, in another type of combination 1 ohm. The first bit answer. First we have how many resistors? Three resistors. We'll take them R1, R2, R3. What is R1 value? R1 is 2 ohm. Then R2 is how much?
3 ohm.
3 ohm. And R3 is 6 ohm. You can connect these three resistors in any way as you like, but total resistance should be, combination total resistance should be 4 ohm. Now listen here. Suppose I am connecting two resistors in parallel, that is 3 ohm and 6 ohm I am connecting in parallel. Okay, this is 3 ohm and this one is 6 ohm. These two are connected in parallel, and this combination I am connecting to the first resistor, that is 2 ohm. 2 ohm I am giving here, series. And these two ends, this end I am taking A, this end as the B, two ends of the circuit. This is 2 ohm, first resistor. This is 3 ohm and this is 6 ohm. First we can calculate the parallel combination. If 6 ohm and 3 ohm, 3 ohm and 6 ohm are connected in parallel, 3 ohm and 6 ohm are connected in parallel, what is the RP value? Equation for RP is what? R2 and R3 are connected in parallel. So R2 into R3, divided by R2 plus R3. That is the equation for two resistors connected in parallel. Means the combination will have a resistance, effective resistance or equivalent resistance is equal to 3 into 6 by 3 plus 6. 3 into 6 divided by 3 plus 6 is equal to how much? 18 divided by 9 is equal to how much? 2 ohm. Got it?
Yes.
Okay. These two resistors we can replace it by, these two can be replaced by a single resistor of 2 ohm resistance. And that new circuit I am drawing here, after replacing these two resistors by a single one, I can draw like this. This is 2 ohm and this is the equivalent resistance of the 3 ohm and 6 ohm connected in parallel. This is the effective resistance of the two in parallel combination, and these are the two ends A and B. This is the end A, this is the end B. This is 2 ohm, this also 2 ohm. This is the effective equivalent resistance, this 2 ohm. Okay. Now they are in series. So what is the total resistance now? In series combination we can add them. 2 plus 2, 4 ohm. Now the total resistance of the circuit between A and B will be how much? 4 ohm. These two together, 3 into 6 by 3 plus 6, that is 2 ohm. And that 2 ohm is in series with this one. So 2 plus 2 is equal to 4 ohm total resistance. The final answer is we can get 4 ohm net resistance by connecting 3 ohm, 6 ohm in parallel and 2 ohm in series with that. In B bit we have to find, we need to get total 1 ohm resistance. We have 2 ohm, 3 ohm and 6 ohm. So 1 ohm is smaller than the smallest, isn't it? The three resistors are 2 ohm, 3 ohm, 6 ohm. And 1 ohm we need to get the total resistance by using all these three. So this 1 ohm is smaller than the smallest. It means what?
Sir, it should be connected in parallel.
Okay, if you connect all of them in parallel, all these 2 ohm, 3 ohm, 6 ohm are connected in parallel, you will get 1 ohm. Means 1 by Rp equal to, we have to apply the complete equation because 3 resistors are there. 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Then substitute the values, that is 1 by Rp is equal to, 1 by Rp is equal to, R1 we have 2 ohm, and R2 we have 3 ohm, and R3 we have 6 ohm, 1 by 6. If you take 6 LCM, then in numerator 6 by 2 is 3, 6 by 3 is 2, plus 6 by 6 is 1, so it becomes 6 by 6. 1 by Rp 6 by 6 means 1 ohm. If 1 by Rp is equal to 1, this is 1 by Rp, then Rp is also equal to 1. 1 by 1 equal to 1, 1 ohm. It means we can get resultant resistance 1 ohm if all are connected in parallel.